Chapter Review 3, question number 9. The table shows summary statistics of the mean daily temperature in Toronto in April 1987 and April 2015. A. Calculate the mean of the daily temperatures in each of the 2 years. So, in the question, we are already given sigma x, and we know that the total number of days in April is 30. So, we can find the mean for the year 1987. So for the year 1987, the mean is 356.1 divided by 30, which is equal to 11.87. For the year 2015, the mean is 364.1 divided by 30, and that is equal to 12.1366. Okay, moving on to part B. In 2015, the standard deviation was 1.02. Compare the mean daily temperatures in the 2 years. So we have already found the mean daily temperatures. So we can see that the mean daily temperature of 2015 is slightly higher. So we can write the answer for B. Mean daily temperature for the year 2015 is slightly higher. We can also see that in the part B, they have given us the standard deviation for the year 2015. Standard deviation basically helps us to understand how spread the data is about the mean. So we already know the standard deviation of 2015. Let us find out the standard deviation for the year 1987. So standard deviation for the year 1987, that is equal to, the formula is the mean of the squares. We already have the squares here for 1987. The squares are 4408.9. So we have here 4408.9 divided by 30 and minus the mean, which is 11.87. 11.87 squared. And when we calculate the standard deviation, we get 2.463. Now, the standard deviation for the year 2015 is given to us already, and that is 1.02. So if we compare the standard deviation 1.02 and 2.463, we can clearly see that the temperature was more spread out in 1987. So we conclude, therefore, the temperature was more spread out in 1987. That answers for the part B. Part C, a recorded temperature is considered normal if the time of the year, if it is within one standard deviation of the mean. Estimate for how many days in April 2015 a normal mean daily temperature was recorded. So here the question is giving us normal temperature, which should be one standard deviation above and below the mean. So first let us find out the day that corresponds to the limit where we have the temperature within the normal range, which is from upside one standard deviation above the mean and from the lower side one standard deviation below the mean. So this is for part C. We have 12.1366 as the mean. So 12.1366 0.1366. So for one standard deviation above the mean, it's going to be 1.02, which is equal to 13.16. And for one standard deviation below the mean, it's going to be 12.1366 minus 1.02, which is equal to 11.12. So we are looking for the temperature between this range, which is here. So let us do interpolation to find out which day does this correspond to. So we have 13.16. The minimum and the maximum temperature that we have for the year is 10.1 and 14.1, which is going to be our end point of class interval. So we put here 10.1 and 14.1. We are looking for a temperature of 13.16, and the number of days are 0 to 30, and let us call this number of days as y. So when we calculate y, we get here 22.95. Now for the lower side, again we have the limit 10.1 to 14.1. We are looking for a temperature of 11.12. The number of days are 0 to 30, and let us call this as y1. When we calculate y1, we get 7.65. So now we need to find out exactly how many days are within the range. Let us understand this by imagining that this is April. Okay, so the April has 30 days. Now the day 22.95 and the day 7.65. So between this period, the temperature is normal. Okay, so we can find out the number of days with the normal temperature by subtracting from 22.95 7.65. So 22.95 minus 7.65, and that gives us 15.3. Therefore, we call it 15 days to the nearest day. And this is the time duration for which the temperature is normal.